Thank you for watching this intro video to our topic on area under the curve for a distribution of means. In this video, I want to talk a little bit about what we'll be covering in this topic, as well as talking a little bit about a comparison between our previous topic where we were looking at answering different area under the curve questions for distribution of scores and comparing it to what we're talking about in this topic where we're answering area under the curve questions for distribution of means. So let's talk about what we'll cover in this topic. We want to talk about what do we mean by distribution of sample means and how do we understand the properties of the distribution of sample means using what is called the central limit theorem. We'll also discuss the standard error of the mean. We'll compute it and then also talk about what that means. We'll be transforming means into z-scores and then using the z-table to answer the same types of area under the curve questions. So you're going to see a lot of similarities between the topics. However, now we're adding on this additional layer of understanding what is the distribution of sample means. So let's just talk about this transition from scores to means. So if you imagine what we were talking about in our area under the curve where we were looking at the standard normal distribution, the z-scores, when we first introduced this idea of answering area under the curve questions, where we were computing a z-score by taking an individual x value, which is an individual raw score, and putting it into our z-score formula, and then trying to answer some sort of question about proportion or probability, either below, above, between two, or outside two. So this is what we were talking about, taking individual scores, transforming them into z-scores. Now what we're talking about in this topic is we're taking individual mean and putting it into the z-score formula. Looks a little bit similar to what we did previously, but what we're doing is we're transforming the mean into a z-score and answering the same questions. You'll notice that there's a different term in the z-score formula, which is the standard error of the mean, which we'll talk about in another video. So we're transitioning again from a distribution of scores into a distribution of sample means. And this helps us transform sample means into z-scores and answer the same types of questions about area under the curve. The probability of obtaining a mean or less, the probability of obtaining a mean or greater, the probability of obtaining a mean between two means, and the probability of obtaining a mean outside of two means. And so we're really leaning into this idea of probability, but we're using the same values that we used in the z-table to help us describe what is the probability. And these concepts are really the underpinning of what we'll be talking about in a topic or two down the road, which is the transition to inferential statistics. And this is really building the foundation of the probability or the chance of a value occurring in a distribution, which has implications to our understanding of hypothesis testing. So that's a little bit about what we'll be covering. In the next video, we'll be talking about the distribution of sample means and how we can understand the properties of the distribution of sample means using the central limit theorem.